Welcome back, Chemistry 30. This is the second booklet of Unit 5, 18.2 Factors that Affect Chemical Equilibrium. So here we'll look at what Le Chatelier's principle is, understand why it works, use the principle to predict how various equilibrium systems will shift in response to a stress, and discuss some industrial applications. So first of all, the Le Chatelier's principle says, when a stress is applied to a system, the system adjusts to minimize the effect of that stress. So ideally, if we're adding something, the system's going to try to use it up. If we're taking something away, the system's going to try to replace it. And the types of physical stresses. So in that straw lab, I added water, which was a stress. Other types of things that could be used here: changes in pressure, changes in concentration, and changes in temperature. And we'll be discussing all of that in this booklet. Okay, so I like to think of it in terms of this. So think of your reaction, your equation as a balance, as a seesaw. Reactants on one side, products on the other. And if you can think of it in terms of that, you'll do fine with this. So let's just say that one of my stresses is increasing the concentration of something. So it's like saying adding an extra person on one of the sides of the seesaw. So as you can see, it's too heavy on one side. We have to have some way of using up that extra weight. If we assume that we can't add anyone else on or take anyone off, if we just shift these people to the right, it would become balanced again. So when you have the stress of increasing the concentration of something, the automatic response is to decrease that concentration or use it up. And we do that by shifting in the direction that uses up that extra amount. So here, move in the direction that uses up the extra person. So in other words, shifting to the right to make it balanced again. And as a result, the direction that I'm moving to will increase. So people on the right will increase because I'm moving to the right. And whatever direction I'm moving away from will get smaller. So it makes sense if you think of this seesaw here. You're adding something or taking something off. So if we're looking at decreasing, so before I move on, 4 basic things here. Identifying the stress. The response to the stress is always going to be opposite because you want to undone what was done. And then there's a direction shift. Then as a result, certain things increase. Whatever direction you're moving to will increase in amount. Whatever you're moving away from will decrease. So if we look at the stress of decreasing the concentration, so in other words, if I remove something, you can see it's out of balance. It's going to be too light on that side, so to speak. So the response is to increase the concentration of what was removed. So to replace what was lost. So of course on this one you'd see that the people would move in the direction to replace what was lost. So move in the direction that replaces what was lost, and as a result the direction that you move to will increase in amount. The side that we're moving away from will decrease. So for now, think of the seesaw. You can get that down. What we're doing here and later on will make sense. So that was concentration. That was the first factor that we looked at. Next, pressure, and then we'll look at temperature. Pressure comes into play when we have different numbers of molecules. Increasing pressure of something is the same thing as decreasing the volume. In class, I like to reference Star Wars. It's like in episode 4 in the trash compactor scene. The pressure increases in that region because the walls are shrinking. It's getting this to be a tighter spot. So if we look at what happens with gases, if I have 4 particles of gas moving around hitting the walls of the container, and if I was to decrease the volume by a half, there's an increased pressure there. These molecules are closer together, they hit each other harder, etc. So what happens as a result, as the gases try to decrease the pressure, try to alleviate the pressure, and they do that by making a smaller number of molecules. 4 molecules becoming 2 molecules. The 2 molecules will exert less pressure than 4 molecules. So that's a key thing to remember. pressure only affects gases, and if the stress is an increase in pressure, the response is to decrease it by moving to the side that has a fewer number of gas molecules. So that's like people there, or this little example here, fewer molecules exert less pressure than more molecules. So we'd move to the side that has fewer molecules, moving away from the side that has more molecules. Okay, vice versa. You may think that decreasing pressure isn't a stress, but it is. So we could decrease the pressure by expanding the room, 3 molecules, and the system will say, oh, we have to replace that lost pressure, we need to increase it again. So you can see here 3 molecules become 6 to make more pressure on the walls of that container. So to increase pressure, we would shift to the side that has more gas molecules, going with the idea that more molecules exert more pressure than fewer molecules. So what would increase? The side that has more molecules. What would decrease overall as a result? The side that has fewer molecules, because we're moving away from that. Okay, so that's pressure. And later on in the book, we'll look at concrete examples dealing with that. Heat. Think of heat as a reactant if it's an endothermic reaction, or as a product if it's exothermic, if it's like that. So the idea here is think of heat as a reactant or product, put it in the equation like we would have done in Unit 3, and treat it as an item that we can increase or decrease. So if the stress was an increase in heat, so if I'm using this one, for example, if it's a reactant, if I'm increasing how much I have, it makes it out of whack. The left-hand side is too heavy. The reactant side, the response is to try to decrease heat. So you can see that in order to decrease it, I have to shift to the right. Move the heat this way. So shift in the direction that uses up heat. Vice versa, if I decreased heat, then this side would be up. And I'd have to replace what was lost by shifting in the direction that replaces heat. So it's very similar to concentration changes. Okay, that's it. So we'll look at an example now. The industrial application here, ammonia plant. So first of all, you're given a stress. What would the automatic response be, or the reaction? Which way are things going to shift, and then what increases and decreases as a result of that. So here the stress is removing hydrogen. So it's like taking hydrogen out. Taking hydrogen off of the reactant side, and of course if I remove something, it's going to get light on that side, so your seesaw would look like this. So if the stress is to decrease hydrogen, the response will be to try to increase it again, and you can see which direction I have to shift things. I'm going to have to shift things towards the reactant side, or to the left in this particular case. And as a result, since I'm shifting things to the left, anything on the left-hand side is going to increase in amount, so nitrogen and hydrogen, and anything that I'm moving away from will decrease. So ammonia will decrease in amount. Okay, you try the next few with this ammonia equation, and then we'll discuss it to see how you made out. Okay, see you soon.